Previously, I've been mentioning fitting a line to our data. So that's exactly what linear regression does. Simple linear regression does so by doing this least squares regression line, which we're going to talk about in a second. Basically, pieces we want to know here, some of the requirements to do linear regression. Just like in order to do a correlation coefficient, we need quantitative data. We need to make sure that our relationship is linear by looking at a scatter plot, and we need to double check those outliers, right? Because we still need that sort of normality of both of our variables. And then we have this one additional piece here. It only makes sense if the observations are independent of one another. So we do need some sort of random sampling or something like that to make sure that we don't have any correlation between our different observations. So an example of this would be like if I were collecting data on statistics students and I was saying maybe looking at hours studied versus exam score, because those are both quantitative, right? This would be fine if I was looking within a class. However, if I had students across different classes, now we're going to have some issues because people within one class are going to be similar to one another and not necessarily independent within the class like they might be if we had randomly selected them or something. So that's sort of what we're looking for with this independence piece. So yes, check, make sure that you have linearity and no crazy outliers that are going to influence your regression line before you start with a scatter plot. Once all that's done, we can create this least squares regression line. And we got some properties to go along with this. This is the best fitting line to our data. Best fitting done so by minimizing the sum of square residuals. All right, we don't necessarily understand what this means at the moment, but when we get to the next page and we define residuals, this will make a little more sense. It is, of course, a straight line. It's usually in this format, though in statistics, we actually see it in form like this, which we'll see on the next page. And that's because sometimes there are going to be more than one explanatory variable talking about exam score, right? So exam score, it may not just be how many hours you study, but it also might be how many classes you've missed and also what your math score was coming into the class, like how much of a math background you had. So we could have multiple variables, and those are usually then added on like this. We'll have an x1 and an x2. So you get the idea. So that's why we usually put the intercept first in statistics, is because we'll have multiple x's. In our class, we just look at a single x, but that's totally unrealistic, and that's why in the computer assignment, the extra credit piece has you look at two different explanatory variables. And when you're dealing with technology, super straightforward and easy to do. So the last piece is what we're going to be doing with the line on the next page. This is sort of what you're going to have to do on the test. We are going to either predict our response variable, or we're going to look at the general relationship by looking at our slope. So both of these things are, well, one's on the next page, one's on the page after, but that's what our next two videos are going to be about, is sort of breaking down what can we do with this line once we have it.